Hi and Assalamualaikum. I'm Nurdiana Atira and I'm going to explain more about the dynamic of scientific change. So basically, what do you know about science? Do you have any idea? Science is a pursuit and application of knowledge and understanding of the natural and social world. It can use through observation and logical reasoning. So back in 16th century, people were expected to be intuitively true because they believed with all the information about what they see and think without evidence and proof. So this is when people try to make a logical reasoning. But all the things are not be used anymore because today we have a theory that makes sense to believe. The new theories are expected to be predictively accurate because it provides evidence. So, what is scientific change? Scientific change happens when any change in scientific mosaic, for example, the transition from one accepted theory to another, or from one employed method to another. This theory is proposed by Berzagian in 2015 from a book called The Scientific Changes. So, what method did they use to make the scientific change happen? Yes, they will use the scientific method. In brief, scientific methods are used to collect measurable empirical evidence in an experiment related to a hypothesis. By using this method, it can attempt to minimize the influence of bias or prejudice in the experimental. Scientific method consists of several processes, which it will be started by asking a question followed by research the existing sources. And then it will formulate a hypothesis, design and conduct a study, and draw a conclusion. Lastly, the result will be reported. But nowadays, we have a new scientific method which is more efficient than before. It is for the modern scientists to perform numerous simulations of the experiment. The new scientific method will start by forming a hypothesis before make observations, and then they will analyze and interpret the data and design and draw a conclusion. If the conclusion states that the hypothesis is true, then it will be proceed to publish the result that can be validated with further experiments. Otherwise, if the conclusion states that the hypothesis is false, then it will be conducted again by forming a new hypothesis. So now, let's watch a video about the scientific method for your better understanding.
The scientific method is about ordinary people doing ordinary things. That includes you, me, and other scientists in the world. The scientific method is just a process or steps taken to produce reliable results to answer a specific question. Maybe you think you don't use a scientific method in your life, but I can guarantee that you do. For example, imagine you wake up on a Saturday and you couldn't find your cell phone. That's an observation. Then you do a little research by thinking about the last time you had it. You suspect that it might be in the pocket of your pants from yesterday. That's a hypothesis. And when you check your pants, you're doing an experiment. But science and life don't always go as planned, and you find no cell phone in your pants pocket. So the second observation leads you to think again and recall what else you did yesterday. You remember that you put your cell phone in your backpack during school. So you decide it must be there, and you go and check. And lo, there it is. Life can continue, and you're so happy that you share the results with your best friend and explain why it took you so long to text them back. Science. These are the steps of the scientific method. And at any step, you can go back and repeat the process. Typically, after you conduct an experiment and conclude that your results aren't answering the question, you go back and try something else. And really, truly, observations and research are going on the entire time. Science is a continually ongoing process. Now let's break down each of these steps into their component parts. All that can be observed with the 5 senses are included in observations. You use your sense of smell, sight, taste, touch, and hearing to make your observations in science. Research is an important step in science because it may answer other questions you have and help refine your experiment before you go down a path that leads to nowhere or conduct an experiment that's already been done. Make sure you use reliable sources to learn background information. Scientific journals and online sources that are vetted and trusted are best. Avoid information from blogs and out-of-date textbooks, as the information might not be reliable. Once you have your research completed, you can form your hypothesis, which is a prediction of what you believe will occur. It is often seen as an if-then statement and is very specific. Here's an example. If gummy bears are placed in water for 24 hours, then they will swell to over twice their original size. It has an if and a then, and uses specific terms that make this experiment repeatable. The experiment itself is made of several parts. Most experiments collect two types of data, qualitative and quantitative. Qualitative data relies on descriptions like soft, yellow, shiny, or wet. Quantitative data relies on numbers like 25 centimeters or 2.3 grams. Once you know what types of data you're going to collect, you can define the variables in your experiment. There is the independent variable, which is the thing you change to see how it affects your dependent variable, which is the thing you measure. So in the gummy bear example, the change in the experiment is that the gummy bears are being placed in water. The dependent variable is the volume of the gummy bear, which is measured before and after it's soaked in the water. A valid experiment will have both an experimental group, where the independent variable is altered, and a control group, which can be used to compare the experimental group to the normal or unaltered version. In the gummy bear experiment, the bears placed in water are the experimental group, and the dry gummy bears are the control, because that's how gummy bears normally are. So to summarize, an experiment should have an experimental group and a control group. The experimental group will have an independent variable and a dependent variable, and the data that is measured and collected can be qualitative, quantitative, or both. Thanks for watching this episode of Teacher's Pet. Don't forget to like and subscribe, and follow me on Twitter at SciencePet.
Now, let's talk about how scientific begins to change. Basically, it was discovered in 20th century as a separate academic discipline or a field of study. It is a study of knowledge, thought, and research as part of higher education at that time. One of the early outcomes of this interest in change was the volume Scientific Change by Crombie in 1963. The historian of science covering the span of science from the physical to the biological sciences, and the span of history from antiquity to modern science. All investigated the condition for scientific change by examining cases from a multitude of periods, societies, and scientific disciplines. The introduction to Crombie's volume presented a large number of questions regarding to the scientific change that remained key issues in both history and philosophy of science for several decades. The idea from Crombie is supported by Thomas Samuel Kuhn. He is one of the American historian of the science for the Structure of Scientific Revolution in 1962. The books basically influenced the philosophy of science. So Kuhn tend to portray the history of science in terms of competing paradigm or conceptual system. So it widened the notion of scientific revolutions on the balance between the continuity and the change in the development of the science. Do you know why science change? In brief, science does not change, but the understanding and the perception of people keep on changing. One of the simplistic answers is that science is always changing because the world is always changing. Next, science relies on testing the ideas with evidence gathered from the natural world. Other than that, it changed because of the development of the technologies used are different and improve a lot from time to time. Nowadays, there are many advanced technologies that have been used to make sure people can find a new things. By this, it can help to know more about the truth behind science. Lastly, it has been truly tested and supported by multiple times of experiments and some lines of evidence. So, one of the students in Texas gave an example that think of science as a person who grows from child to adult. The new experiences and evidence change a person's perception. As they grow up, Things they previously believed change because of the new evidence and experience. These are the example of technology used in science. So you can see the development of the microscope, telescope, and stethoscope that have so much improvement than before. So back then, most of the technologies are made up from wood because it is the simplest one and it is the easy to find. But nowadays, it changed to be more and more advanced. So this is the other example. So do you guys remember the old theories about the earth being flat? So these theories has been concluded based on the limited methods of research which was available in those days. One of the method used is by observing. But nowadays we all know that the earth is not flat. It is in a spherical shape. Our new method of research and technologies help us to know that. So does the earth change from being a flat or spherical, or just we change our way of seeing the facts? So here's the thing. The natural world is always changing along with what we know about it. Another example is, in early 20th century, Marie Curie discovered that the chemical element radium was giving off thermal at steady rate. At that time, no scientist could explain why this was happening because they thought that mass and energy as a separate quantities. But Albert Einstein had a new interpretation for Curie's evidence. He discovered that mass could be converted to thermal energy and vice versa. So, by the Einstein's new interpretation of the existing evidence, it obviously changed the scientific knowledge. So now, let's watch a video for your better understanding. It also contains example for your new information. So, happy watching!
Science is all about understanding how the world works, but it's also a process. Science is a systematic way of observing the world and doing experiments to understand its structure and behavior. So, a scientific idea is an explanation for how something works, or the truth about some aspect of the world that was figured out using the scientific process. Scientific ideas are far more reliable and more likely to be true than other kinds of ideas because they're based on evidence. Coming up with new scientific ideas is all about gathering that evidence. For example, we used to think that light was a wave. Then, Albert Einstein and others collected evidence that light can also act like a particle. It turned out that light was both a wave and a particle, and it can act like both in different situations. But it was only through gathering more evidence that we were able to figure that out. Scientific ideas come from evidence, but it takes brilliant thinking to imagine them. New ideas come from collecting evidence and looking at it to figure it out, but often it isn't as simple as it sounds. Some of the biggest scientific leaps in history were made by people who looked at the same evidence and drew conclusions that nobody else had thought of, but which did a better job of explaining the data. For example, the theory of relativity showed how Newton's laws of gravity were only a simplification and don't work at really high speeds. The equations for relativity were not obvious, and so it took a lot of creative thinking to come up with. But even when you have evidence and are able to explain that evidence with clever thinking, the ideas aren't guaranteed to be accepted. For example, the idea that earthquakes were caused by gigantic tectonic plates moving across the surface of the Earth was rejected and ridiculed. Only when evidence became stronger did people start to accept it. So, how does this happen? Well, through collaboration and debate. People come to work together to collect new evidence and convince each other of a new idea through their interactions.
So next, we will go through to the benefits of the scientific change. Firstly, it helps to satisfy many basic human needs and improve living standards. For example, nowadays, there's a lot of technology used in order to make people's life more easier, like car, laptop, and other things. Secondly, it helps in medical in order to find a cure or to detect disease. On top of that, it also helps to know new things about our world and surrounding. For example, we can know more about the solar system, the gravity, moon, sun, and many more. And last but not least, it helps in education so that people will always try to find a new one and it can be spread to our new generations. So that's all from me. Thank you.